Right, so we did this one on the last video, right? So now we want to keep going, and you're going to see what's happening in section 7.2 is, well, what if we now they put multiple stuff in there itself? So what, what's actually going on here, okay? Now, the good thing is, right, so since they're inverses of each other, they should technically cancel each other out, and you should just get that number out. But we still have to check if it's still in the range of sine inverse, right? So for sure, these literally cancel out. However, will this actually give me pi over 8 is the question. Okay? And that's what we're going to figure out right now. So we're doing the exact same thing. Well, sine of pi over 8 will just cancel out, and you want to see it. So again, sine inverse goes from negative pi over 2 to positive pi over 2. So is pi over 8 within our interval? Again, right, just looking at the first half of the portion. You could just look at the unit circle, right? We're looking just from here to there, this half of the unit circle. And where's pi over 8? Well, pi over 8 is right here somewhere, right? So since it's somewhere here, therefore it's in the range, right? We don't have to actually evaluate it. So we know automatically they just cancel each other out and we just get pi over 8. Those are the easiest options when it comes to it. However, the next question is a little tricky when it comes to it. And you'll see why that. So yes, they still technically cancel each other out. However, 5 pi over 8, we go over here, where's 5 pi over 8 roughly, is going to be somewhere over here. And if you notice, this part of the picture is not in the inverse of sine itself. So now the question becomes, how do we find one that's also equivalent to here, right? Because it has to be in this range itself. Now the best way I've tried this out is just slowly break it down. So what we want to do is we're going to break down the entire unit circle into 8 parts. Because, why 8? Because it's over 8 parts. So from 0 to pi, we're going to break it up into 8 parts. So in other words, 4 and 4. Okay? And now what we want to do is, since it's 5 pi over 8, I'm going to shade 5 parts of an 8 whole. Right? So that's 5 parts, like little pizza slices of the 8. So right here is 5 pi over 8. Okay. Okay. Right, so now, again, right, that's technically not in the range because I want it from here to there. So I want to flip it. So think of a mirror image of itself, right? A complete mirror image. So if I would just cut this out and, and fold it right at the center. So if I just cut this paper and fold it together, we want to figure out what point would this go to here. Again, right, if I just cut this entire circle out and fold it right in the middle, I want to figure out what point will that match to here. Okay? And it's actually not that bad to realize, because if we're missing 3 parts to get to the half, that's kind of what you want to do here is 1, 2, 3. So this point should touch that point there itself, or the equivalency when it comes to the inverse. Well, what is this point here? Well, this is 1, 2, 3. This is 3 pi over 8. Again, 3 parts out of a total of 8 parts individually. So essentially, what we're doing is we want to find what this value is, and you're just making a little chart out, right? We're literally just making pie charts itself. You evaluate, okay, 5 out of 8 whole. And now, if it's not in the range of the inverse we're looking for, we're going to have to fold it, in this case, in half. And you'll see cosine we're doing in the opposite direction. But the reason why we cut it in half this way is because sine goes from here to here. So we have to fold it in half vertically. You'll see in a little bit cosine folds it in half horizontally because it goes from 0 to pi as well. Okay, but for here, all we want to do is literally, if I fold it into this fold here, where would this point go into the ranges here? And it should touch at 3 pi over 4 or 8. So our answer is literally 3 pi over 8. And that's how we're going to do these type of scenarios itself. Okay, it's a little tricky and it's a little practice when it comes to, but once you get the hang of it, it's actually not that bad. Okay, so let's try the next one. So this is a little easier when we did it on the last video. So cosine inverse of negative 2 radical 2 over 2. So if we convert this is negative radical 2 over 2, e is equal to cosine theta. And then do the same thing, right? When is cosine equal to negative radical 2 over 2? And since we're in the x's, it is 3 pi over 2. And the other one is right here, 5 pi over 4. Okay, so again, cosine, like I said earlier, is between 0 and pi, so it goes this way. Okay, so here's 3 pi over 4, and here's 5 pi over 4. So which one's in the range of cosine inverse? Only this one, right? However, if we did the exact same process we did up there, so we're going to cut it into fours, okay? So, right? So here's the one we know, so we know for sure it's going to be this answer. But I want to show you what happens if I flip it so you can see exactly what's happened. So here's 5 pi over 4. Now, because cosine goes from here to here, I'm going to now cut this out and fold it horizontally because now it's going this way. So hopefully you notice the difference. So if I flip this, right, so if I fold this up, where would this point go into here? And notice it's literally the exact same point of 3 pi over 4. So we're not just getting rid of it, it actually gets engulfed into one single question, a single point. So a lot of these times, instead of two options, these two options end up being folded into one point itself. So when it comes to these points are exactly the same, but eventually becomes 3 pi over 4 because that's in our range of sine, of cosine itself. Okay, I'm sorry. So that's the little tricky part when it comes to it. That's where you got to be very careful when it comes to knowing the ranges of the inverses themselves. Okay. So let me show you guys another one here for E. Okay. So now for E, so same thing, they cancel each other out just like sine. So all we have to check is sine or is pi over 4, pi over 12 in the range of cosine inverse. So again, we'll just redraw the picture. Well, pi over 12 is this little sliver right here, right? Somewhere there. I don't know the exact value, but we just care about finding it. Well, is pi over 12 within the range from 0 to pi? Yes, it is, right? So this is automatically just pi over 12. We had to do nothing to do it, just like we had to do nothing over here, because it's always in the range automatically. Okay, so those are the questions you guys probably like the most when it comes to it. Now this one's a trick question, okay? Because it says negative, right? So we're going to just draw that out. Right, so negative 2 pi over 3. So remember, positive going this way, so therefore negative goes in the opposite direction. Okay, so if we're doing negative 2 pi over 3, well, let's see. If I go back to unit circle, if it's negative, so if it's easier, I'm going to plot this into 3 parts. So negative pi over 3 is the same thing as, like I said earlier, right? Positive 5 pi over 3. Negative 2 pi over 3, therefore it is over here. Oh, sorry, over here. Okay. So negative 2 pi over 3 is equivalent of 4 pi over 3. You guys see that? If I subtract, so it's if I minus negative pi over 3, I should be here. If I do another one, it should be here. So notice I'm subtracting 1 from the top, right? So essentially you're starting at 6 pi. So minusing pi gives you 5 pi. Minusing another pi gives you 4 pi. Minus another pi gives you pi. Minus another pi gives you here, right? And you're just going in the opposite direction, okay? So now that we know it's here, and we know cosine inverse goes from pi to 0 pi, again, notice we're going to do the same thing. We're going to flip it when it comes to it. All right, so we have 3 parts, right? So this is, if we do it ordinary, this is pi over 3, 2 pi over 3, 3 pi over 3, and so forth. And now we want to figure out if I fold it this way, because this is cosine, where would this land, right, if I fold it? And hopefully you guys can see now, it would land right there, right? If I literally fold it in half this way, it would touch here. So therefore, the question now becomes, what is this point? Well, we just talked about this is pi over 2, pi over 3, sorry, 2 pi over 3. So essentially, this ends up being 2 pi over 3 in the inverse of cosine. So hopefully that helps you guys out when it comes to it. Now, I'm going to give you guys a hint before we go any further in the next videos, is if you have the inverse on the outside, like this, on anything. So inverse on the outside, inverse on the outside. Okay, like that's like questions C, E, and F. Okay, you are always going to do this folding stuff. You're going to draw it out and then fold it respectively where it's going to be. Okay. The reason why I say that is on the next couple sections, which is going to be in which is 7.2, is notice the inverse is on the inside, which gives you a different concept you have to do. So if the inverse is on the outside of the function, so notice it's on the outside of the function being evaluated, you're going to do this folding and lap stuff. So you're going to just draw it out and then fold it respectively where it's supposed to be. So it's like the folding stuff, okay? I'll talk about the next video, which is 7.2, what happens when it's on the inside, which is 7.2. Okay?